Learn all about full text indexing basics with Azure SQL and SQL Server, featuring a very interesting and potentially grim demo this week on Data Exposed MVP Edition. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed MVP Edition. Today, I'm joined by John Miner. John, thanks so much for joining us today. Can you kick us off by telling us a little bit about what you do?
Yes, Anna. Hi. Thank you for having me. My name's John Miner. I've been awarded the MVP for 7 years, and I work for a company, Insight, and I am a digital architect, data architect. And today we're going to be talking about full text indexing and why it's important.
Awesome. I love the topic, and I think you're the exact right person to do this. From what I understand, you've been speaking about full text indexing for a while, as we'll see shortly from some of your slides. But I did want to kind of start off like, why is full text indexing important, and why is doing it with a tool like Azure SQL or SQL Server useful?
Excellent. So, in the slide deck, and I can get to it right now if you want, Anna.
Yeah, let's do it.
Excellent. So, go back one slide. We're going to talk about modern data types, right? Today's large object binary types can store up to 2 GB information. That's a lot of information, right? And this could be unstructured or structured information. It could be like a Word document. It could be text, right? And typically nowadays, Microsoft supports like varchar, varbinary, XML, JSON. Obviously, the engine's backwards compatible, so text and image will be out there. They'll be removed, obviously, in the future releases. So the reason why we want to use full text indexing is we do not want to use a full table scan or a clustered index scan. We want to actually do a seek, and full text indexing allows you to do that. So we need to have some type of database to actually test this out on, right? One of my favorite shows a bunch of years ago back is Grimm, right? And it's the brother Grimms. They actually had a bunch of fairy tales, and they never ended out really happy. Someone always died in them. Okay, but we're going to pull that text from the internet, and we're going to load it up into a database, and we're going to do full text indexing on it.
Cool.
So let's look at search pattern one. The traditional ways to do searching back in the day, Anna, was like the like command, right? And we know that if we do like and then %b, it's not searchable, right? So if we're looking for, the word wolf, and there's always a big bad wolf eating someone in the fairy tales, right? Basically, if we do %wolf, it's not going to find anything. Or if it does find something, it's not going to use that index where we really want to. So there's been in the past 2 different ways to do it, a like command or a pat index command. And I'm going to skip over to the demo right now. And it's actually going to show you that we're going to get a non-optimal search. So if we look at our demo here, we have a table called fairy tales, and it's in the Grimm database. So we can see Grimm up the top. We can see DBO table underscore fairy tales. If we look for the word wolf and we execute it, we actually get the title of the adventures, right? So,
Mhm.
and we also have the actual text of the adventure, okay? So it did get hits, and we did get 7 results. But if we look at the execution plan here, okay, we're getting a clustered index scan, and that's not optimal,
Mm.
okay? So let's try this again with the pad index, and guess what? We're going to get exactly the same results. We're going to get the same data set, and we get the same execution plan, okay? Let's try to fix it, right? Let's maybe make a non-clustered index, okay, on this quote unquote the text of the fairy tale, right? So create non-clustered index on the fairy tales given the field, and we're going to try this, and oops, it fails.
Mm.
So how do we fix this problem, Anna?
I don't know. Why does it
Well,
why does it fail actually?
it fails because you cannot have indexes, okay, on a large object binary type. It's not supported.
Mm.
It's not in the actual data page, okay? So to fix this, what we have to do is we have to create a full text indexing. So in this time period, we don't have enough time to go through the steps. to show it in a demo, but I'm going to tell you what you need to do. You right click on the table, you go to the full text index wizard, and it's right here. It's listed here, step 0. Then what we're going to do is we're going to select the table. Obviously, we already had the table, and we're going to pick the primary key, okay? Need some type of way to identify that row. Then we're going to pick the column in which we want to search. So it's my tail, okay? There's 2 ways to do change tracking. One's to be manual, another one's automatic. Now, the problem with automatic is it's going to kick this job off with the full text indexing every time a change happens. So for systems that are really busy, we don't want to do that, okay?
Right.
Last but not least, we want to create a new catalog. The catalog can have 1 or more indexes. And what we're going to do is we're going to create this index in it. And then we're going to schedule a time to run the update to the catalog. Okay. Once we have the full text indexing, we can actually use different keywords to actually solve this problem. So I'm going to go back to my deck. Okay, of course, right here, minimize, and talk about why that's good. So the performance results of the first test was we did a full table scan. That wasn't really good. And the second one, we could have a full clustered index scan. Still not good, right? We tried adding a index, okay, non-clustered to the large object binary, and there's some limitations in the engine. One is the number of fields and number of bytes. Again, this deck's been a while in my repertoire presentation, so things change. Please look at the MSDN documentation for up-to-date information. What we're going to do now is we built the full text indexing. There's a bunch of keywords that allows us to now use a function call instead of a actual index search, and that function call will be going ahead and returning a full table value result, and that will give us the pointers to where the data is, okay? So contains is for exact matches, FREETEXT is for fuzzy. We can see also contains table and freeze table are the same thing, but the only difference is that it adds ranking. So tabbing back to the demo, let's take a look. We're going to do the same search, okay? We're going to execute it, and we can see now we have the same results. What's the execution plan? If we move up, we can see the execution plan now is using a table value function, like I said, and it's using that index, and it's going to be a lot quicker on large data sets. Obviously, we're not going to see the performance on such a toy database.
Right.
Now, if we do the contains table, we get a ranking. Execute. And so we can see before we had the matches, but we didn't know which one is the best match. And from this, we can see that the actual 37th tail, okay, the wolf and the 7 little kids is the best match, okay? So back to you, Anna. Do you have any questions?
Yeah, this is really cool. Can you explain just a quick moment, like what the ranking is actually doing? I know I should know, but I don't.
It's going through and it's trying, and again, I'm not an expert at it, but there is other functions that I'm not showing here. Please read my article. There's DMVs you can go out there. It actually goes ahead and tries to figure out the number of occurrences of the word, and if the word wolf happened more in one article versus another, it might rank it higher. If we're doing a combination of words like big bad wolf or something like that, it might have a higher ranking. Now, the question you might say is, does this ever go wrong? And in life, things go wrong, right? So we can go ahead and we can look at fairy tales and say, hey, let's take the fairy tales, okay? And I'm gonna run this first. I'm gonna say, hey, let's do this query, look for the word wolf. We got 7 results, right? We see that 22 is here. I'm gonna null out the data for 22, okay? We can see now if I run this again, the data is no longer there. But guess what? If I do my search again, it's actually going to work. Why is that working?
Yeah.
Because we have not updated full text index and we set it to manual. So it's a thing that typically you do like an ETL load at night into your database that you allow and use to do search, okay? And what we need to do is we need to say populate the index again. And now if we go here, we're seeing that 22 is showing up as number 4. And guess what? 22 is gone.
Gotcha. That makes a lot of sense. So, like best practices, how do you kind of mitigate this sort of situation? And then, kind of off of that, like what are some situations where you've actually seen this used in real life?
Excellent. Good questions, Anna. First one is best practices, right? Run your ETL once a day, or after you run your ETL, you have to do an update, right? So it's just one of those things. You can do automatic, but again, on a transaction system, it's something that's really busy. You don't want to kick off an index build when it's really a busy time of the day. So I would say try to schedule it. Okay. Second thing is that I'm looking at the performance results page on the demo, and we can see now that we've turned that index seek into now scanned into a seek, and that's really great. Again, we talked about the toy database. It's small. You're not going to see great timings here, but when you have huge data, you're going to see a lot. And again, best practices, run it at night. As for use cases, okay, how do you apply the technology? Two examples I've done in the past. One is I worked at a bank and we had help desk tickets from a COT system. We imported the data. This is going a long time ago, back into 2005, and ran this. So full text indexing's been in SQL Server and Azure SQL for a long time. Okay. Last but not least, the other application, we had an application that was making bad XML. Okay, for the middleware, we wanted to search for errors and we couldn't because we couldn't parse the XML. Well, guess what? We threw it into a text field and we put a full text indexing on it. And next thing you know, we could actually do searching.
Amazing. Cool. John, this has been so useful. I've learned so much about full text indexing. I think this was the perfect amount of information. I love the demo. I really feel like I have a good handle on it. For our viewers, we're going to include several references to things that you've done in the past and resources to learn more about full text indexing. I just want to thank you so much, John, for coming on the show. To our viewers, go ahead and check out those references. They'll be in the description. Like this episode and leave us a comment and let us know what you thought about this video and the wolf scenario. We hope to see you next time on Data Exposed.